Hi everyone, good evening. So we are now going to look at the session number 8 on the topic light, reflection and refraction. So in this session, right, we are going to introduce the concept of refraction and how do we observe this refraction. So in almost like the previous 7 classes, right, we were doing about the reflection part. We talked about the plane mirror, we talked about the spherical mirrors. How do we analyze the image formation because of the mirrors? By using the ray diagram concept and also by using the mirror equation concept. In this session, what we will be looking at is we look at the concept of refraction. So what is this refraction of light? So refraction of light is a common observation that we see around us. Like if you happen to see any object which is inside the water, like we'll see a fish inside the water. While the fish is really at some particular depth, so this we can say is what the real depth of the fish. But the fish will appear to be a little bit closer to us. So this we can call it as what? The apparent depth. This we can call it as what? The apparent depth. It is not just about fish. Even very common things, right? Like you put some coin into water, you will see that the coin will appear closer to you. So why is it happening? It is happening because of the concept of refraction. So some of the things that we observe around us, right, they all happen because of refraction. So refraction we can say is the bending of light. So bending of light rays is basically bending of the light rays. When the light rays move from one medium to another medium. So when they are going to bend, when they move from one medium to another medium, and that is what we will be putting as the refraction. So what is refraction? The concept of refraction is basically if the light rays are moving from one medium to another medium, right, then we will see that there is going to be bending of the light rays. Like if you see over here, what is actually happening is, if you think about the normal that you draw, okay, the light ray is starting from the object. What is the object here? Fish is the object. It should have gone like this. This should be the normal path, or we can say the original path. So how is it bending? We can see how is it bending. This is bending away from the normal. So when the light rays are coming from water to air, so this is what inside water is there, outside what is there? Air is there. When the light rays are entering from water to air, they are bending away from the normal. So normal means the normal that you draw to the boundary between the water and the air. This is one way of bending. So where we'll have light rays, they will bend away from the normal. Then there is one more way. Light rays can sometimes bend towards the normal also. The two kinds of bending possible. Light rays may be bending away from normal, which happens when the light rays are entering from water to air. The other possibility is if the light rays are entering from air to water, right, what is going to happen? They will bend towards the normal. So this bending of light rays, when the light rays are moving from one medium to another medium, right, they will be either bending towards the normal or they will be bending away from normal. And this bending of light rays is what we call as the refraction. And refraction results in common observations like this. When you look at an object inside water, right, it will appear to be coming closer to us. Okay, so the apparent depth concept is basically because of the refraction. So we'll see what is this refraction, guys. So refraction is basically what we are calling as the bending of light rays either towards the normal, that is the one observation, or the light rays can be bending away from the normal. So light rays may be bending towards the normal or they may be bending away from the normal. Both these things is what we are calling as refraction. And when the light rays are going to bend towards the normal, when the light rays are going to bend away from the normal, we will be able to understand in further discussion, right? So like what we said is, if the light rays are going from water to air, what we said, the light rays are bending, as we have seen in that representation, right, they are bending away from normal. So when they go from air to water means what will happen? The light rays will be bending towards the normal. The light rays are going to be bending towards the normal. So these are the two possibilities of bending of the light rays. So why when they go from water to air they are bending away from normal, and why they are bending towards the normal when they are going from air to water will depend upon the speed of light. So how the speed of light will change from one medium to another medium, and this dependency of speed of light on a particular medium, we will learn it through the property called as refractive index. So we will learn about all of this as we go into the session, guys. So the bending of light rays is happening because of what? Because of difference in the speed of light. Speed of light will be changing from medium to medium, and depending upon that we will see that light rays are going to be either bending towards the normal or they will be bending away from the normal. Okay, and we'll have a property that is going to be representing the speed of light in a particular medium relation to the speed of light in vacuum, because light will travel at a speed which is approximately equal to 3 into 10 power 8 meters per second in vacuum. I think in one of the previous classes, right, the first class itself, introduction class itself, we talked about it. In vacuum, light is going to travel at how much speed? 3 into 10 power 8 meters per second. But when the light is entering into some other medium, right, the speed will be changing. It will not be 3 into 10 power 8 meter per second, it will be something else. How much will be the value? We will be relating it to what? The refractive index as a property of the material or a property of the medium. Okay, so refraction we will see in two cases, guys. Either the light rays are going to bend away from normal when you move from one medium to another medium, or they will be bending towards the normal. Why this is happening? Because different medium, the speed of light will be different, and we will relate this to what? A property called as refractive index. Okay, now whenever we look at the refraction as a phenomena, the refraction phenomena, just like the reflection we have laws of reflection. Here also we have a laws of refraction. Okay, so look at this laws of refraction. If you have the incident ray, refracted ray and the normal to the interface. So you have the incident ray, refracted ray and the normal. And remember, guys, refraction means the light rays are going from one medium to another medium. It can only happen when the two medium are what? Transparent. If they are not transparent, if they are opaque, means what? Light rays cannot go from one medium to another medium. Both the medium must be what? Transparent. So if we have the incident ray, refracted ray and the normal, like in the previous case, right, we have water, the example that we have showed you, and air. The light ray is coming from water. This is what is the incident ray. We have the normal, and it is bending away from normal like this. When the light ray is going from water to air, it is bending away from normal. So this is the refracted ray. So we have the incident ray, we have the normal, and we have refracted ray. All the three, they will be lying in the same plane. This is the first law of refraction. In fact, if you remember, right, in reflection also we said almost similar thing. What did we say? The incident ray, normal to the surface, and reflected ray there. Here we have refracted ray. The ray that is getting into second medium is called as what? Refracted ray. There incident ray, normal and reflected ray, all three will be lying in the same plane. Here what is happening? Incident ray, normal and refracted ray, all three will be in the same plane. The second law is the ratio of sine of angle of incidence. Sine means in mathematics you will be learning about it. So there will be something called as trigonometric functions. What do we call them as? Trigonometric functions. And one trigonometric, these are mathematical functions. One trigonometric function is this sine function. Like you will be putting it as sine theta, where theta is what? Angle. Theta is what? Angle. So we will see what are some of the standard values of these trigonometric functions. But look at this law first, then we will try to understand. The ratio of sine of angle of incidence means here, angle of incidence means what? The angle between the normal and the incident ray. I am putting it here, you can observe, this is I. Okay, and the sign of angle of refraction means the angle between the refracted ray and the normal, that is R. The ratio of sine of angle of incidence and sine of angle of refraction will be a constant for a given color of light and for a given pair of medium. Means if you look at a particular color of light, for that the ratio of this sine I by sine R, sine is what? Trigonometric property. Sine I by sine R will be what? Constant. For a given pair of medium, means if you are looking at water and air, then sine I by sine R will be equal to what? Constant. This constant will depend upon what factors? It will depend upon the color of the light that is used and will depend upon the medium. And this law is basically called as what? Snell's law of refraction. What is this law called as? Snell's law of refraction. And after some time, right, we will be learning about what will be the value of this constant also. We will learn about what is the value of this constant. So what are the laws of refraction, guys? They are very much similar to the laws of reflection. What is the thing? The incident ray, normal and refracted ray. Incident ray, normal and refracted ray, all will be what? They will be in the same plane. That is one. Second thing is what? If you have the angle of incidence, angle of refraction, their trigonometric function, sine function is a trigonometric function. Like that, we will also learn about some more trigonometric functions in 10th standard mathematics. You will learn about there will be a function called as cosine function, or we also call it as what? Cos function. Then you will be learning about tan function. Okay, like this you will learn about some trigonometric functions. But here in physics, right, we just need to understand the values of sine function for some common angles. That's it. Okay, so sine I by sine R, right, sine of angle of incidence by sine of angle of refraction will be a constant. This constant will depend upon what? It will depend upon the color of the light, whether it is the yellow color light or red color light or blue color light, and it depends upon the given pair of medium. So here, what is the medium that you are choosing? Water is one medium and air is the other medium. This law is called as what? Snell's law for the refraction, and we will see after some time what will be the value of this constant also. Clear, guys? So this is what is the laws of refraction, and we said we are going to use this sine. It's a trigonometric function, right? So look at this, guys. Maybe we can remember in mathematics you will learn about this. If the angle is 0 degrees, sine 0 will be 0. If the angle is 30 degrees, then sine 30 will be half. If the angle is 45, then sine 45 will be 1 by root 2. If the angle is 60 degrees, these are some of the common angles we see, right? If the angle is 60, then sine 60 will be root 3 by 2. If the angle is 90, then sine 90 will be equal to 1. Okay, so just try and remember these values, guys. Beyond that, in physics we will not get questions. Mainly we have to remember what? The common trigonometric function values. Sine 0 will be what? 0. 30 degrees means sine of the 30 degree value will be what? Half. 45 means sine of the 45 will be equal to what? 1 by root 2. What is the value of root 2, guys? What is the value of root 2? Root 2 value will be, what is it? Approximately 1.414. Sine 60 will be what? Root of 3 by 2. Root 3 value is what? 1.732. And sine 90 value will be equal to what? 1. So these are the trigonometric functions and their corresponding values. Okay. Now we will get into the idea of the refractive index. So we said speed of light in a particular medium will be related to the speed of light in vacuum by a property called as what? Refractive index. So what is this refractive index? Generally, right, for a medium, the refractive index is represented by either the symbol n, because in some textbooks we will use symbol n. Some textbooks will put a symbol like this. This is spelled as mu. How do you spell it? As mu. Some textbooks they will use symbol n. Some textbooks they will use symbol mu. Okay. So what is these symbols for? They are for the refractive index. So what is refractive index? Refractive index of any medium, right? N. I am using the symbol n here, but we can also use mu also. N will be equal to, this is the definition, speed of light in vacuum. already we know the value for that. What is the value? 3 into 10 power 8 meter per second. Divide by speed of light in the medium. So whatever medium for which we want to measure the refractive index, right? What will be the refractive index value? Speed of the light in vacuum by speed of the light in the medium. Now if you see this, right, this generally we will put it like this. C is symbol for what? Speed of light in vacuum. Divide by V. V is the symbol used for speed of light in the medium. If the speed of the light in the medium is less, V is lesser. V lesser means what? Because V is in the denominator, right? Then the value of N will be more. So if in a medium the speed of light is less, it means what? The refractive index value will be what? High. The refractive index value will be what? High. So we will call these kind of medium as optically. So what do you call them as? Optically denser medium. Optically denser medium means what? For them the refractive index value will be higher. And that will mean what? In those medium the speed of light will be what? Less. If the speed of light is higher means it can come maximum up to what? It can come maximum up to C. Then that means what? The value of refractive index will be less. Okay. And we will call these kind of medium as what? Optically lighter medium or rarer medium. Optically lighter medium or optically rarer medium. Okay. So the refractive index value, right? Least. How much least it can come to? For vacuum, that is the least it can come to. For vacuum, the value of N will be equal to what? 1. That is the least value it can come to. Otherwise, the refractive index value will be always more than 1. Okay. So if you look at some of the sample substances we normally talk about, right? We can see the refractive index value. For air also it is not exactly 1. It is what? 1.0003. But we can take it as also 1. Air also we can approximately take it as what? 1. And you see ice. What is the refractive index of ice? 1.31. Water 1.33. Alcohol 1.36. Kerosene. Quartz. Okay. Turpentine oil. Benzene. Crown glass. Okay. Canada balsam. Okay. So this will be used in making one very popular optical instrument which you learn in the higher standards. Okay. And then we have rock salt. Then we have carbon disulfide. Then we have flint glass. Then we have ruby. Then sapphire and diamond. So we can see diamond is pretty high, 2.42, which means what? Higher the refractive index means what? The speed of light in the medium is that much lesser. Okay, so this is about the refractive index values of some common materials. Okay, so if you look at the Snell's law, in the Snell's law what we said, the angle of incidence, this is a normal, so this is the incident ray. Okay, let's call it as what? Medium 1, that is where the incident ray is there. The medium 2 is where the refracted ray is going. This is the normal. This is a normal. Okay, the refracted ray, like in the previous case what we had, it was bending away. Let's say it is also bending away here. This angle is called as what? Angle of refraction. So the Snell's law states what? Sin A by sin R is equal to what? Constant. We said constant depends upon what? The color of the light and the medium 1 and medium 2. Sin A by sin R will be equal to refractive index of second medium by refractive index of first medium. Second medium means what? The medium in which the refracted ray is present. First medium means what? The medium in which the incident ray is present. So the modified Snell's law is what? Previously what we said, sin A by sin R is equal to constant. Now what is the value of constant? It is nothing but N2 by N1. This is also, we call it as N21, means refractive index of this ratio, right? Refractive index of second medium. This is how we will call it as second medium with respect to first medium. So we will take a ratio of the refractive index of second medium divided by refractive index of first medium, right? What do you call it as? N21. and this is the modified Snell's law. So previously what we said, sin A by sin R is equal to constant, but the modified Snell's law is what? The sin A by sin R value is equal to what? N2 by N1. Okay. Now we look at some sample problems on this. Look at this question, guys. These are some of the problems that we have taken from the NCERT and NCERT exemplars. Look at this. A ray of light traveling in air enters obliquely onto the water. So means the ray of light is going from air to water. Does the light ray bend towards the normal or it will bend away from normal? So whenever the light rays are entering from the air to water, so air is what? By looking at the refractive index values, it's an optically lighter medium. Water is what? Optically denser medium, because for the air it is 1.003 and for the water it is what? 1.31. So 1.36, sorry. So which means this is the denser medium. So when the light rays are entering from the lighter medium into the denser medium, the light rays will be what? They will be bending towards the normal. So remember, guys, when the light rays are entering from lighter medium to the denser medium, how they will bend? They will bend towards the normal. The question is why? Why they are bending? They will be bending towards the normal because here, right, this is the normal. Let's look at the normal. Okay, so the ray is coming like this. Bending towards the normal means what? Like this it is bending. Why it will bend towards the normal is, in the denser medium the light will not be able to travel with that much speed. It will be able to travel only slow. So to cover some distance, right, if it is not bending towards the normal means it will take a longer path. So since the speed is decreased, it will take a shorter path. So the speed of light in the denser medium will be what? Lesser, and hence it will be bending towards the normal. If you have the ray of light entering from in the other direction, denser to lighter, then what is going to happen there? The light rays will be bending away from normal. Why? Because there the lighter medium, the refractive index value is what? Less, means the light will be traveling faster there. So this is how we look at the bending of the light rays, guys, in case of refraction. When the light rays are going from lighter medium to denser medium means they will bend towards the normal, because in the denser medium the speed of light is lesser, and when the light rays are coming from denser to lighter medium means they will bend away from the normal. Okay, so this is what is the behavior of the bending of the light rays when they move from one medium to another medium. Okay, let's look at the next question, guys. Light enters from air to glass having refractive index 1.5. It's not like we have to remember all the refractive index values. Even in the previous problem, right, I was able to recall that air is 1.0003 and water is 1.36, but it's not a strict requirement that we have to remember all these values. Okay, broadly if you have an idea, that's sufficient. Okay, light enters from air to glass. Glass, what is the refractive index? 1.5. What is the speed of light in the glass? So we need to find speed of light in the glass. The speed of light in vacuum is given as what? 3 into 10 power 8 meter per second. Remember, guys, we have a straight formula, right? What is the formula? Refractive index N is equal to what? Speed of light in the vacuum by V. V is what? Speed of light in the medium. Means V will be equal to what, guys? C by N. So we take the V this side, bring the N that side. V is equal to what? C is 1 to 10 power 8 meters per second. Divide by what is the refractive index value is 1.5. Remember 1.5 ones, 1.5 twos, because 1.5 into 2 is what? 3. 1.5 into 2 is what, guys? 3. So what is the answer going to be? 2 into 10 power 8 meters per second. What will be the answer for this, guys? So for any medium, right, the refractive index value is equal to what? What is the refractive index value? Speed of light in the vacuum divided by speed of light in the medium. Speed of light in the vacuum divided by speed of light in the medium. That is the refractive index value. Which means on rearranging, what we are going to get? The V value will be equal to C by N. What is the V value? C by N. Okay. C is what? 3 in 10 power 8 meter per second divided by N is what? 1.5. So finally what will be the answer? 2 into 10 power 8 meters per second. Okay. We look at one more question, guys. This is rather a theoretical kind of question. Look at this. The refractive index of diamond is given as what? 2.42. In fact, we also saw in the table, right, diamond was sitting at the very last. What is the meaning of this statement? So whenever somebody is giving us a refractive index, right, first of all, what is the meaning of the statement? It tells, because recall the previous formula, previous problem we discussed a formula, right? What is the formula? V is equal to C by N. Means from this, right, we can find what is the velocity of light in that particular medium. So the velocity of light in that diamond will be equal to what? 3 into 10 power 8 meters per second divided by 2.42. And this also tells that the speed of light in the medium is how many times that of speed of light in the vacuum? 1 by 2.42 times that of C. C is what? Speed of light in vacuum. So V value will be equal to what? 1 by 2.42 times that of the speed of light in the vacuum. So this is what we will be able to understand. If somebody is giving us one more statement, right, like speed of, refractive index of diamond is 2.42 and maybe glass is 1.5. Then what we can say by looking at both of them, if somebody is giving us a diamond, the refractive index is 2.42 and glass is what? 1.5. Then we can compare and tell that, okay, since the refractive index of the diamond is more, diamond is what? Optically denser medium. Means the light will travel slow in that. And refractive index of glass is what? 1.5. Means it is optically a rarer medium or lighter medium. So the light will be traveling relatively faster there. Okay. So this is what is the information we will have whenever we are given the refractive index values. Okay. So this is what we have to cover in today's session, guys. And tomorrow's class, right, we will look at the idea of the image formation because of lenses. So we'll talk about two types of lenses mainly. One is a convex lens and concave lens. And image formation because of the lenses, right, is based upon the idea of refraction of light. Okay, so we'll talk about this in tomorrow's session, guys.